what we said on Tuesday. We have listed the changes that we want to make to the model. We have identified that we want to make many of them. And we have identified the sort of roles and responsibilities within the team, what sectors can be covered by, and then the tasks that I can perform in parallel, mostly the general ones, mostly general tasks on my side. And we also said that it's better for us to work as a single group at least once a week. And we keep the Thursday calls, which are the earlier in the day calls that pose fewer problems for everyone. And we also said that we may work in parallel, especially for Tatiana and IPEC, to develop the model, have bilateral exchanges with me, and then report back on the Thursday session with everyone, and then continue with the changes to the model on an ongoing basis, whether offline or online on Thursday, as time allows. So what we had planned for today, or for the beginning of these sessions, is to review the type of data that are available and then propose the type of changes that we could make to the model. So it's very important at first to agree these are the changes required to represent the concerns or dynamics that we have identified in our long list. And then once there is an agreement on what is the best way forward, we could start making changes to the model. We make changes to the variables and equations, and then we start the calibration, making use of the data that we have. So I said that for today, what we're going to do, or the plan, was to review the list of changes, review the data available, and then agree on what changes should be made to the model in a very specific way. So what variables we would want to change in one sector, say agriculture or energy or tourism. And once we agree on the change that we could make, we go ahead, we modify the model, and then we add the data and we move towards calibration for that specific sector and the changes that we have made. So I hope that this can be a process that is run primarily by you as a team, but of course under the coordination of Tatiana, IPEC, and anybody else that wants to.
Который будет отвечать за 4 соответственных сектора и всех остальных.
And I'm happy to give you advices, confirm what type of changes could be made, pros and cons of each option, so that we move practically into the model update phase, where we're actually working with the model directly. Once we have changes that are approved collectively and the calibration works fine, I can then transfer these changes into a master model or a master copy of the model that, of course, I can make available in Dropbox so that you all have access to that at any point in time, that we use as the model that incorporates all the progress or the validated progress that we make in any of the sectors and by any of the participants. Would you agree with this proposed way forward?
Вы согласны с этим предложением?
Understanding based on what we discussed on Tuesday?
Yeah, I think that's what we discussed basically.
Okay, good. So then I propose that we start. I see that, Tatiana, you have shared the data that you have collected so far. You have also shared an updated list of the required model changes with some text highlighted in yellow and additions to the file. How do you want to organize the session? We have the possibility to work in 2 groups on 2 models, but we all follow more or less the same, or we all work on the same model and we take turns. Maybe Tatiana, you start first on agriculture or energy, or IBEC can start first. Or we break the session in 2 parts so that the first hour and a half or 2 hours are being led by Tatiana and the following ones. Very flexible. Just let me know what you think is the most productive way.
I'm not sure if we are quite ready to work by ourselves at the moment, because my concern is the following. I did not have much time to look into the data available. Therefore, okay, we could start with agriculture, basically, and add traditional, to have traditional, sustainable, and organic agriculture. However, there are some things within this. So how they differ? They differ by labor costs. They differ by amount and types of fertilizers. They differ by tilling. They differ by pest management, weed management, yields, etc. So we can sort of add these variables that we are seeing already, which I highlighted in yellow. I'm not quite sure that these are all of them, that this list is exhaustive. What do you think?
I would think that we need to get started and see how the process goes. And as we make the changes, you might say, well, that is an important factor, but we don't have data. Let's discuss. Should we include it anyway, or should we leave it out, putting in a note on the sketch of the model to indicate that something more needs to be added? And we can start using the color coding we discussed before. Maybe we add the variable so we know it's there, but we highlight it in gray font because it's not being used at the moment, or because it's empty, right? It's just without numbers. But I think the only way to implement this process is to get started, see what's difficult, what is easy, and practice.
Okay, so let me just find where my model is. So we're still working in the old one that has some issues with
Yes, I would suggest to work as a group on that one, because we also have all the variables highlighted in blue. It's the one that you're more familiar with, and it already shows what are the types of changes that we need to make. And then as we go on, I will make the other model available in parallel, but I need a couple more days to take care of the general tasks. Tatiana, would it be okay for you to open the model with Vensim DSS, share your screen, then we review together the agriculture changes we want to make one by one, or we can prioritize if you want to start with sustainable, organic, and conventional. And then we go into that sector, review, we decide on what needs to be changed, and then we start adding variables.
Yeah, let's do that.
So first step, review quickly what we have here, which has mentioned it in 2 minutes. And then we compare it with the change we want to make.
So we have here agricultural land used for crop production, which is like the total land that is fed by the total agricultural land and by the share of agricultural land used for crop production. Okay, then there we have this influences pesticide application, chemical fertilizer application. I think, yeah, okay. Let's see what we have first. So with chemical fertilizers, they're also influenced by average rate per hectare, share of sustainable agriculture, which I suppose we are saying does not use them, or I don't know, for each crop type. What this means again?
So first, look at the variable. This is the share of sustainable agriculture.
Yeah.
And the ZIDZ is to make so that when you divide something by 0, the model doesn't stop.
Okay. So if they're 0, so they don't stop. Okay, fine. You have sustainable agriculture. So if it's 0, then this is not if the sum of land used for sustainable agriculture by each crop type. Well, then we have initial fertilizer application, which is chemical fertilizer application, which possibly comes from somewhere else. I think this is another. This is initial. Okay, chemical fertilizer application. Okay. And then we have relative application, which is chemical fertilizer by initial chemical fertilizer. The same thing we have pesticides. We have initial. We have relative. Pesticide application is also influenced by average per hectare, the same for chemicals. Okay, and here agricultural land used for crop production influences crop plant under irrigation, because this is a part of it. Here we have share of agricultural land irrigated. Okay, we have a policy switch to sustainable agriculture. We have additional irrigated land switch as well, which was supposed to start from 2018 and reach 5,875 hectares by 2021. Crop shares in agricultural land. We also have for cropland under irrigation, we have the shares for different crops, and then total irrigated land, total rain-fed cropland. Yeah, okay, so this is basically the total land minus crop shares in agriculture and minus crops under irrigation, crop types. Agricultural land used for crop production multiplied by crop shares by crop type minus cropland under irrigation.
So what this does is that it takes total land used for crops, and then it divides it into type of crops, so that we have hectares by crop, and then it subtracts the amount of land that is irrigated, so that all that you have left is rain-fed.
Okay, this is total. Fine. Okay. That's what we have here at these points, which go from agricultural land used for crop production. I can see a branching out into traditional, sustainable, and organic. What do you think?
Well, let's see, in this sector, where is sustainable agriculture mentioned?
It's not, but chemical fertilizer and pesticides applications are different for all three types of agriculture.
Yes, so you see that you have the share of sustainable agriculture at the top.
Yes, okay.
Right? Where is that coming from? Because clearly sustainable agriculture is being dealt with somewhere else, right?
Where is that coming from? How?
Is it coming from policy switch to sustainable agriculture?
So one way to find out is
How do we know
to
where is that coming from?
use the hand.
Maybe.
Okay, either you can use the causes tree to see what is affecting that as an option. And you see it comes from land use for agriculture and sustainable agriculture. And then either we know where these variables are, or if you don't remember, you can close this one, go to edit at the top menu, and then find, and there you can type in a share of sustainable agriculture. There is that off, you wrote OD instead of off, that's why it doesn't find it. Okay, then click on that and do edit, find again. It did find it right here, but find again.
Share off. Yes.
Okay, click on that, okay, and then edit and go to the last option, find again, F3. You can remember F3 as an option, and you see it shows up here, right? So this is where it's actually calculated. It's comparing the two options. Then if you do edit, find again, you can see whether it's being used in other places as well. Okay, so this is a way of identifying where these indicators are calculated or being used. Then we saw before that this was based on land, right? Land that is sustainable or conventional. Now click on the list of sectors at the bottom left corner. Okay, see you have the two sectors just below where you are, land use for crop production. If you look at this sketch and what we have here, on the right side, we have two stocks, land use for agriculture and land use for sustainable agriculture. So this is also where the policy is having an impact. You see, you have the switch to organic farming, which would be sustainable. But then you have the policies here that determine how much land is being used in each of the stocks. So if you want to introduce organic, sustainable, and conventional, you have to start from land. So we have to begin making changes in this sketch, because then we know that land, try and click on land use for sustainable agriculture and open the uses tree. We see that land is affecting one of the key outputs that we have is the yield and production, the share of agriculture organic by crop that we used before. So land for us is the starting point. The policy tells us use these many hectares with sustainable or organic practices. Everything else comes after this variable, okay? Comes production, the use of fertilizers, and we'll add pesticides as well, and so on and so forth. So if you want to introduce sustainable, organic, and conventional, this is where you have to start modifying the model. Is it clear, the process?
Yes.
Review the model, identify where the topic is being addressed. In this case, it's addressed in an incomplete way. Policies affecting land. So land is the first step to then determine production and all the other indicators. And so land is the first sketch to modify. Now, how would you suggest to change the model based on the goal that we have? So if I look at the list, we have item 7, add sustainable in addition to organic, 2 policies with different costs and impacts. Labor cost, fertilizer use, tilling, pest management, weed management, yields, and cost of product. So how can we change the model to reflect that?
I think organic can be considered a subset of sustainable because it's more strict, right? So we might have another stock, or we might leave this sustainable as such. Okay, this is sustainable, but then here we'd have to change to sustainable, beside organic. So we would have to change this all first to sustainable and then add a subset for organic somehow.
So discuss among yourselves about what actual changes you would want to do. If you add a stock, okay, if you agree that you need land for organic agriculture as a stock now, then what is the inflow? What is the outflow? So think about how that could be implemented with the model. Feel free to exchange among yourselves I will not interrupt. When you reach a conclusion, then I discuss it. And I tell you if it's okay or not. But I want to give you that independence and responsibility at the same time.
Thank you. That's nice. Okay. So, colleagues, what is your input? What do you think? So I would just basically, because in our program, it is not quite clear when they're talking about organic or sustainable. I think they're using the term interchangeably. Whereas in my mind, there are two different things. Well, organic is much more strict than sustainable. And I would want to differentiate that because there are different policies related to that. Because organic, basically, that you don't use anything apart from very natural things like, I don't know, it's very difficult and very labor consuming. So not everybody would agree to that unless there would be a market that would buy it at a higher price, basically. The same for sustainable, but still. Okay, so we can leave a stock for sustainable and have a stock of organic land used for organic agriculture going out of it, or we can have any inputs. What do you think? I would probably add this. And it would come from the land used for sustainable agriculture, and this would be change. Wait, what do you think? Yeah, we can have two, by the way. Sustainable to organic and land. We can have one of the inputs from here. Oops.
So the underlying assumption in this case is that you go from conventional land to sustainable and then to organic. Is it possible to go straight from conventional to organic or not?
I think it is. Besides, you can already be organic. Like we have plum production in the south. They haven't used anything for a long time, so they're organic already.
Okay, so if, and you can confirm, if you have initial land that is organic, initial land that can be sustainable, sustainable to organic, or from conventional to organic, what flows you need to include in addition to the one you have now?
I'm afraid it will be very ugly looking, no?
Well,
how do I add this thing?
Well, you first delete, yes, this one. Then you have to go straight, click once on the stock of origination and once on the stock that is your arrival point, and then you can move things around. Yeah, type the variable name. Now you can move the stock or the variable land used for agriculture to organic agriculture a bit to the right. Move maybe the change from sustainable to organic land to the left. You can right click on the sign similar to infinite sign in the middle of the flow. And if you just click on that sign that you have now at the very left, right? If you right click on that one, you can decide where to position the word. So you can say position it to the left side so that it doesn't overlap with the other arrow that comes down from the right.
Okay.
So attachment left.
Seem to have, yeah. So we have land for agriculture, which is further divided into organic and sustainable, and we have a possibility of transition from sustainable to organic land.
Yes. So if you agree that this is the correct flow of information, then we need to start thinking about what equations we use for the two additional flows that you have added and the stock. So equations and units.
But here we have initial land used for organic. Shall I change it to sustainable? Because how do we keep track of the changes? If I now change it to sustainable, we have to change the value here. So
yes, so that is only organic. And then we need to think about the numbers. But the numbers, let's keep that for later. Let's just first focus on getting the variable names and the equations right.
Okay, let's change that first. Right?
Yes, we have an initial value for organic agriculture.
Which would be affecting that.
Why do you want to add the change from traditional to organic land? What do you have in mind? A time series, a policy?
No, that would be transition rate, actually.
Isn't that the same as the flow?
Yeah. This is rate to define the flow.
The rate is a percentage. What do you have in mind in terms of mathematical formulation? So we start thinking about the equation to use. So what equation would you use for the flow land use for agriculture to organic agriculture?
So here we would have, let's say, hectares per year, right? And here we would have percentage or something like this. Or maybe this is a table.
Let's define one aspect first.
Yeah.
When you think about the equation, would you want this to be user-driven? Meaning you want to introduce the number of hectares as an external variable? Could be a policy, could be an underlying assumption that you don't want to change because it's not a policy, just say this is what it is. Or do you want it to be endogenous, meaning determined by the model based on other changing conditions, such as, for instance, if you want to include the price for organic products, maybe the price will be one of the factors that would determine how many hectares of land are transitioning from conventional to organic. So first think about whether this should be external, policy-driven, or internally calculated.
Good question. We will have difficulties with prices here, maybe.
And I mentioned prices just to give an example of what could determine an internal change, but it could be anything. Like Asel was mentioning before, there is no data. And if it's difficult to understand what is driving that change, then maybe make it exogenous, make it an assumption for now, an average rate of transition that you can change in different scenarios, for instance. Now, this is an interesting process that you're following now, because normally, if you develop a causal diagram first, you're able to identify the causes of change, and then you just focus on the equations, right? But when you have an existing model and you want to modify existing variables, then you should already have the diagram or the main dynamics in your head, and then only decide about how do I make this change? Do I make it policy-driven? Do I make it internal? So think about the potential use of the model. When you discuss it with your local counterparts, will you say, let's assume in this scenario that organic agriculture is 10% of land, so exogenous, policy-driven? Or will you say, let's assume that market conditions change, the climate impacts increase, and so farmers start to realize over time that organic is better and it's more climate resilient. It brings premium prices. And that structural change in the sector leads to the expansion of organic agriculture. You see, in the second case, it's not an assumption. In the second case, we have identified what makes that flow change so that we can build internal dynamic equations to represent it. But then, or farmers tell you, oh, no, I would never do it unless there is a policy that forces me to do it because I don't have the knowledge, because I don't think it's working. Then in that case, you have the answer. Keep it external. Simplify the problem and say, this happens if we have 10% of organic land, or this happens if you have 20% of organic land, or this happens if you have no organic land. And you just set up different scenarios instead of having the model generating the outcome in an internal way, endogenous way.
And this is a good question because at the moment, I think the process is rather internal. So if a farmer finds a market, then he may well transition to organic. But I don't see that as how can you force somebody into being organic? I mean,
well, you can, if you do it as a what if, it's like, what if they realize that it's important? What if the market demands this type of production and so people decide to switch? If you're convinced that there are advantages and you want to do a cost-benefit analysis, we can also assume that it happens and then see what the outcomes are.
So can we have, let's leave it as, we can tweak it. How much conventional, how much sustainable, how much organic do we have? And what effect it will have on the profitability, etc. In this case, we'll be able to do the cost-benefit analysis, or?
Yeah, you can keep it simple. I mean, this decision rule can always change, of course. If you start mapping the consequences, if you start mapping the use of fertilizers, different prices, different costs and profitability or yield per hectare, then you can always decide later to endogenize or not the decision to transition land cover. It can come at any stage.
Yeah, let's make it in external then. And used for agriculture. This is total. So we are not changing that. And we do have like this traditional left. This is total. So we have sustainable, we have organic. Where is our traditional? Or do we not need it at all?
Let you think and see if you can find the solution.
Yeah, okay. I don't think we need the third one. Colleagues, anyone? I feel like I'm alone talking here again. Can we have some input? Okay, so I don't think we need traditional. Let's have the land that we are using, which is then in part sustainable and then in more part organic. And we will determine the share of sustainable and the share of organic exogenously. Here, the rate of transition, this is hectares per year. Then we can have here a table, right? To transition it.
Yes, it could be a table. The table could be represented as actual number of hectares, as a percentage of hectares of the total amount of land available. Or, as Hazel mentioned, it could be based on market demand. So you can determine what is the demand for a certain number of hectares. So you can say you could have a desired number of hectares to be compared with the actual ones, and the difference determines the transition.
Like you do here.
Somewhat similar, yes. We have done the desired formulation before. Yes.
Andrea, there was a comment from Ermek in the chat box. He wonders if we did, whether or not we took into consideration horticulture when we were reviewing the agricultural sector.
Sure, we did, but it comes different place. Here we have livestock manure, livestock management, livestock emissions. It will come a bit later. We are going just through this list that I sent in the chat box. You can download it. And you'll see the questions that we are adding at the moment. That's why we are starting from land, because it comes first, and then at any rate it comes first. But we do have horticulture, which we call livestock. Yeah, so it's all here. So let's come back to our land. We were talking about transition from traditional to organic land table, or here we have transition to organic. Let's say here we will transition to sustainable. Policy sustainable agriculture, I agree. Desired share of agricultural land,
sustainable.
Yes. Switch endogenous sustainable farming. Policy land converting to organic farming. Again, this is going to be this is elsewhere. This is elsewhere. Desired share of agricultural land. So we click here. Policy land converted to organic farming. Let's change it here, just because it's easy.
I will show you a trick. If you want to change all the organic to sustainable at the moment.
I think it did show us once already.
Okay, so if you go to view and then as text.
Yes.
But this is something you have to do very carefully, because it can generate more damage than anything else.
Yeah, that's why
if you go to the bottom, you see find and sub at the very bottom of the screen of the window.
Okay, organic here.
Right, if you write organic, find organic, and then sub, you write sustainable. And then you click on sub once, see what happens.
This is my phone.
So this is found here, but this is way at the bottom. So when you have these symbols, you know that you don't have to change anything. So you have to go back to the very top of the list of equations and click at the very top next to land. Okay, now click on sub again, and let's see if it finds something else. No, so just say no in this case and go to the next one.
It doesn't.
It doesn't. So it seems that you have already found all the cases where organic was mentioned based on what you see here. So it was mentioned in a very few cases, but you see that there is organic there.
Yeah.
So
it's not found. Why?
Normally it should find it. Try. Oh, because you wrote organic correctly, right? Yes.
I think so. Yes.
Yes. I'm just thinking what could be the only reason.
I think I didn't save it, but it's still showing here.
No, it doesn't matter. So try again. Click at the top. You have organic.
Here.
And you click on sub again. It's right there, so it should find it immediately.
Nope.
Okay, let me try my version. Let's see if it's the same. So I've never seen that problem. I don't know whether it's a Vensim version issue or something else.
Might be, because I have...
Yeah. I'm not hearing.
It's an older version.
Yes. So if I click on find, I can find it.
Mm-hmm.
If I click on substitute, I have the same problem.
Yeah, I can find it as well, but not substitute.
So if I go then, let me go as catch and find the comment you have. I'll just do a quick test. I think you have that comment with the indication sustainable equal organic. We need to find it and remove it.
Yes.
And then we see, where is it?
Agricultural land indicators.
Maybe it's just that one. Maybe it's just that one comment that creates problems. So I have removed it from my version. Save and reform and clean. And then search for organic. No, somehow it doesn't find it. And not with substitute. It finds it when I say find. And then if it finds it, then I can do copy paste any way of sustainable. It's faster, but not as fast as it should be. Say find, yes, it finds it many times. So I can share my screen quickly so you can see how this, how I would do it at the moment. Should be able to see my screen anytime now. Let me know if you can see it. So if I do find, I can identify where that is and then do copy paste, Control V of sustainable, and then find and again. And we have to be careful to see where the changes are to make sure that we're not changing again the underlying settings. If we do it this way, one by one, then we know that all the instances where organic is mentioned will be replaced. And the one thing to do, I will do it quickly now, but the one thing to do next, when we go back to the conventional version of the model with the user interface, is to do model reform and clean, which is a function that makes sure that all the code is properly organized and sorted so that there is no problem. We're close to the end, and I suggest after we do this, then we take a break. Okay, so here we are. Now, let's do view as sketch and do model reform and clean. Actually, let me save it with a different name just in case. Yeah, so the model runs, so it seems that everything is fine. So I'll go back to stop sharing my screen.
Not about horticulture, basically, but about gardening. And quite correct, we did not have it in our agriculture, but we should, because this is quite a large portion. But we have fruits, right? We have fruits as one of our produce.
Yes, and there is some aggregation in the model. You have to decide which aspects are more relevant.
We can add, Ermek, we can add fruits here because we don't have that. Because this is, I mean, it's quite a large portion, like the whole Issyk Oblast and stuff in the south. And there's quite an export of dried fruits as well. And basically, organic land is something that is used for gardening, for like fruit trees. So can we add here something? How do we add something here?
I suggest we take one change step by step.
Okay.
Changing subscripts is something I will do later because it changes a number of different things at the same time. It requires data inputs everywhere. So let's complete this one. This is also an important message for model development. Do one change and validate it. Do one change and validate it. And then move on to the next one. Don't jump in different directions. But write it down, and of course we can address it. So should we take a 10-15 minute break now and try and take a break every hour? Okay, thank you.
Agricultural land minus land used for organic minus transition rate to sustainable farming.
So you know that when you add the flows, when you add the flows, the model Vensim updates automatically the stock formulations, right? So this is the only change that the software makes to the equations automatically.
But doesn't it have to be changed in agricultural lands? Okay, this is the inflow. Then the outflow is land used for agriculture to organic agriculture. And then it should be land used for sustainable agriculture, not transition rate.
No, so the stock can only be modified by the flows, right? So the inflow is changing agricultural land, and that is fine. And then the outflows are the variables called land use for agriculture to organic agriculture, and the variable called transition rate to sustainable farming, which is the outflow of the land use for agriculture and inflow to the land use for sustainable agriculture.
Alex, sorry for disturbing you. It seems we don't have Orlan with us.
Okay.
Do we need recording of this session in Russian? If not, then we may continue in English.
I don't know. Let's ask the colleagues who needs translation. Okay. Then it's okay, right? So it's okay. Then we have land used for sustainable agriculture, which is change in sustainable agricultural land and transition rate to sustainable farming. So this is something, it has to come from here as well. Why is it?
What do you mean it has to come from here?
So we have like two inflows, which seem to be very, well, quite the same. So we have transition here to sustainable farming, fine. We are transitioning. And here we have change in sustainable agricultural land, which is...
see where that change in sustainable agricultural land is used, if it's used only in this case or in some other place. So use the hand and then the uses trees.
Land used in sustainable agriculture. Okay, and then carbon sequestration. Productive organic agricultural land. This one we have missed actually, which should be productive sustainable agricultural land now.
Yes, there are a couple more changes to organic that has to be adjusted, yes. I actually noticed that in my case, I thought it was working fine, but it didn't work fine at all, actually, that word changes. Maybe the model is a bit too big or there's something off in the code.
You had like 12,000 variables and that worked, so...
Yeah, maybe, I'm not sure. But it can certainly fix it, that's not a problem, I can take care of that.
So then, yes, it is used in other places as well.
One of them is total change in agricultural land, you see, that is being used there. So this means that we can either make so that organic agriculture comes from existing agricultural land, or that it comes from other land that is not agricultural land at the moment. That's why we have the two inflows.
Okay. That's a good question. Let's assume it comes from agricultural land. But basically, if you're talking about fruits,
well, you can delete that extra flow. It's no problem. If you think it's clearer by not having it, so we avoid any potential questions.
Moreover, we have one policy discussed at the moment, which is to convert, or let's say to allow all unproductive lands for gardens, for fruit gardens. So it is a possibility. So it's a policy discussed, but I think it's a very sound one. It's not done at the moment, but there should be a possibility for that. So Nurlan is, I think, yes, it's here.
So if we, just to follow up on that, if you close here, do you have scenarios loaded in the simulation?
У вас есть сценарии, по которому...
Do you have scenarios loaded at the moment? If you go to control panel to see what simulations you have loaded.
Where? Datasets.
Datasets, yes. So you have the two, yes. So if you close here and then we look at some of the results to understand how the model works. If you click on the graph now, having selected change in sustainable agriculture.
No, it's not changing at all. How do you do this thing when you zoom in the graph?
No, let me see. I think it's not loaded. Try and go to control panel again, just in case. Double click or remove the three scenarios. Not here. So yes, move them to the left. And then load them again. You should probably load them from the same folder, from what you have on the left side. We probably have them if you scroll down.
A good one, which was that, actually?
Yes, one of these KGGEM, one, say the November 15, maybe, or yes, so the ones we use for the final meeting, and the green economy one as well, just below.
This one?
These are two BAU. And then if you take the G November 15 and the BAU November 15, that should be okay. Okay, then click on the graph. I no need to resimulate this.
Nothing.
Okay, click on land use for sustainable agriculture. Okay, oh, I see why. This was probably a change in organic agricultural land, and that's why it doesn't load results. Okay, yes, the software is right. So I'll share my screen very quickly so that you can see the changes there. Okay, so this is the same sketch, the original one. So if you look at change in organic agricultural land, we see an increase, temporary increase between 2020 and 2040. Then we see that this policy is affecting both the change in organic agricultural land, but also this desired agricultural land conversion. So we see a corresponding decline in conventional agricultural land to compensate that increase in sustainable agricultural land. So that if you look at the stock, we have a decline in land use for agriculture that is conventional, but at the same time, we have an increase in the land use for sustainable agriculture. So at the moment, this flow and this other flow can be used somewhat interchangeably, basically. This would be a direct transition from what you already have in place, and this one is the introduction of new organic land, which, if demand remains the same, so this desired agricultural land remains the same, then automatically, for consistency, reduces the amount of land for conventional agriculture. So this formulation is done to represent two possible policy mechanisms, but also to address the fact that if you expand the land that is desired because of an export strategy, because of a strengthening of domestic agricultural production policy for economic growth, then there is no constraint being posed to the amount of land that you need to transition from one category to the other. So in a way, if there is an increased demand for land, there is no need to reduce conventional agricultural land. You will only have an increase in the sustainable one. So that was the reason for having these two dynamics.
So, but back to our screen here, fine, this still remains. The logic should be okay here. However, what for direct conversion to organic, do we need to add this as well? These two things as well, like these two flows?
Mm-hmm. So first, let's fix the equations for the flows and the stocks.
Mm-hmm.
Then we need to identify possibly a policy change that determines what type of transition you want to have in place, like we have here that we just discussed here. So would you want organic agriculture to come from sustainable, to come from conventional, to come from somewhere else? Right? That's the idea. So how do we complete then the equations?
You mean let's look at all of the formulas, right? Or
I couldn't hear you well. You were breaking up. What did you just say?
I said, so do we look now at all of the equations and then we think? Okay.
Yes, all the black variables have to disappear, meaning that they have to be fully formulated.
So this is land used for agriculture to organic. We can have like maybe right? We can have some kind of, I don't know, we can have...
Feel free to try different methods in this case. One flow could be an exogenous time series, another one could be a growth rate, another one could be a policy. Just test the different options.
This is just an assumption. I have no idea. How much organic ones do we have?
Yes, for now, focus on the equations. So use not really random numbers, but somewhat okay numbers, not validated. Don't mix model creation with a calibration. It's a...
See, until 2050. We have a model until 2050, right? For 2010, 2100.
Sorry, it was muted. So it's 2050 up to now, but you can add whatever duration you want. Simply Vensim would not use the number after 2050 when the simulation ends. So that if you extend the simulation to 2100, if we build in climate change more explicitly, then some of the inputs will be already adjusted.
If we have that, that would be 1, or would that be dimensionless, or 1/2? I think 1/2. There's a comment somewhere. I cannot see the chat while I'm sharing the screen, so it's a bit weird. It would be great to have like voice comments if you have them, colleagues.
I'll stay quiet for a while, so I leave the room for for you and the team to try and move ahead.
Andrea, I asked Ermek to voice off his comment to Tatiana because she cannot see the screen. However, let me take this time to translate his comment for you because it was Russian. Ermek wonders, the degree or the level of land degradation in agriculture as a consideration, as some kind of an impacting factor, was it incorporated in the model? Was it anywhere reflected in the model? Land degradation as a factor.
We were going to add it. If you look at the Word document, we have under 9, add a variable for soil degradation, including impacts from sustainable practices for crops and livestock. So this was point number 9 that we were going to add. It's a bit of, we have said that already in the table, but okay. So let's assume we have 1% for initially used for organic agriculture. Then change from sustainable to organic land would depend on how much sustainable we are converting to organic. And we would have to have either a table as well or some other relation. So this is directly to organic. Let's have that here, another table. Let's define this table. I'm just assuming this works. This is something I'm just making up, but I'm assuming that we'll have conversion from both directly from traditional. Let's see, I mean, if we go directly to all organic, then we have half there, 40% there, and we have 5,100. Okay, this is going to be, I always forget this. Okay, and then land used for organic agriculture is going to be the direct transition, change from sustainable to organic, plus change from traditional to organic. Okay, this is initial value. That's right. Initial value is initial land. Hey, we are done. I'm not sure if it's correct, but at least it doesn't light up in black anymore.
Okay, so are you confident that everything is fine?
No.
At this stage? No? At least the equations are complete. So what are the 2 tests that we can do once you have identified the variables and the equations? First, we can review the units, but now it's a bit messy because we have the other unit errors. And the second one is to do the model check. So let's go through the units manually together. If you close here. So if you move your mouse over the variables, so land use for agriculture, the stock at the top, the unit is?
Hectare.
Then these other one has to be hectare as well, the second one, and the third one has to be hectare as well. Then what is the unit of the flows?
Hectare per year. Okay,
so all of them have to be hectare per year.
They are.
And the equation has to reflect that it is in fact hectare per year.
This would say, well, we didn't say that it's incorrect, but let's see. So this is land.
So you can go into the variable and then click on check units. And what check unit does, it calculates if the unit that you use in the equation is the same one that shows up in the unit field. So in this case, you're taking land use for agriculture, which is a stock, hectares, multiplied by transition from traditional to organic table, which is dimensionless per year. So when you multiply them, you have hectare per year. Okay, so that's correct. So this is the simple test you can do just to verify consistency. Then the next step, what is it? That you run the model and see if something goes off. So we changed the simulation name. I normally put in, as usual, whether it's a baseline or not scenario, I put in the date and then version 1. Because during the day, I end up running maybe 50, 60, 100 scenarios. So I have many different versions, as you can imagine.
Is it baseline? How do we call that? It's not baseline. Right?
For now, you can call it baseline. It's fine because we're not looking at whether policy is active or inactive.
It has errors that cannot be simulated. Yes, I can.
Okay, so yes.
So subscript appear on the right, but crop types.
Okay, so let's see what is this problem with the subscripts. This is not an easy topic, so let's try and proceed step by step. And let me know, please, if you understand or not what I'm saying. So the message that we get here is the following. We have certain variables with a subscript called crop types and other variables in the same equation without that specific subscript. So let's open, for instance, land use for agriculture first, the stock at the top. You see that, first of all, when we look at the equation, just under the word equations, you have subscript crop types. So this means that you need to generate the results for this variable for the subscript and the elements in the subscript crop types. So if you look at the center of this pop-up window, you have subscripts and range. If you click on the drop-down menu next to range, yes, and then you click on crop types, you see that these are the current crop types that we have. So this means that land use for agriculture will be calculated for grains, wheat, barley, corn, potatoes, vegetables, and the remaining group of everything else. Right? Now look at the equation. You have change in agricultural land using crop type, so disaggregated by crop type, minus land use for agriculture to organic agriculture without that specific crop type. So what you can do to add it, an easy way, is to go back to the subscript drop-down menu and click on ranges, the first one that comes up. Not on a specific type. Click Click on the drop-down menu first. Okay, and then you can click on range.
Jesus, range.
Yes, because you want to use all of them and not one or the other.
Crop types, and then I click range. That here, no?
Okay, then here you find the range called crop types, meaning you're going to use all of them because you want to have land use for agriculture being calculated for all of them. So if you click on crop types, then it gets added as a subscript. You can remove grains, exactly. Okay, so this makes so that there is consistency. You have change in agricultural land by crop, land use for agriculture to organic by crop, because you will want to decide what crop is transitioning from conventional to organic agriculture. And then what transition rate to sustainable farming as the extra flow is also by crop type. So now you can click on check syntax and OK. So we know that this variable is fixed, but there are many others that we have added. So we can move ahead and look at for instance, the flow land use for agriculture to organic agriculture. Now this is completely new. And so what we need to do in this case is to add that information on crop types. But remember, we also want to generate outputs from this variable by crop type. So we need to click on subscripts in the equation on the left side, just under the word equation or equations.
I did add this here already.
Yes, but you need to add it also to indicate that the variable has to generate the outputs. So you did well. You have to add it there in two places. You need to add it in two places. Yes. No, remove. I will explain what you've done in just a second. Okay, so here you have to add in the subscript field, you have to add crop types. So you can click there and then click on crop types. So we are generating outputs for this variable according to crop types. Then in the equation, you have land use for agriculture that uses crop types, and you have to add crop types also to the transition. Now, this is assuming that you want to show a transition that may differ for different crop types from one to the other type of land. Now you can click on check syntax and close.
You want to change for all users of land use for agriculture, yes?
Yes, so basically you change it once and it's asking you, do you want to apply the same changes for the places where this variable is also used? For instance, the next step would be to go check the stock of land use for organic agriculture.
Change from sustainable to organic is not, for some reason.
Yeah, that is the other flow. It should be added there as well. Crop type. Okay. And then we go to the stock. Under subscript, sorry, there is a bit of delay in what I see on the screen, I guess. Here you have to add it at the top. You have to click on the subscript button and add it there so that the results will be reported for each crop type. But for all the other variables, you have it. You may want to add it also for the initial land use for organic agriculture. So you can identify how many hectares are organic for each crop type. Okay. Now, on the subscripts, we have additional variables to fix. The initial land use for organic agriculture is one of them. So at the moment, what do we have in this case, in this variable? We have one number, 0.01. What is the unit in this case?
Percentage, dimensionless. Oh, no, wait. This is percentage, so it's dimensionless.
Okay, but how is this variable used in the stock of organic agriculture land?
It's hectares.
Mm-hmm. So pay attention. I know it's not easy, especially at the beginning. Name the variables so that they tell you what is the content of the variable. So if you call it initial land, my expectation is that this is hectares and not a percentage. Otherwise, call it share of land that is organic. But then make sure that you pay attention to the equation that you use. Okay, so let's assume this is the initial share of land used for organic agriculture.
Going to be dimensionless, right?
Dimensionless, yes. Now remember one thing, we said before that this one has to be estimated for each crop, right? So next to the subscript, where you have the subscript field, you need to add crop types. Just add crop types and not the specific crops. I will show you why.
Here?
Yes.
Okay. Just a second.
I will show you the two ways to do this in case. Okay. So this is the first one. Now, if you, sorry to ask again, but if you go to range and select crop types, just to see what these are, how many are they?
7.
There's 7. So this means that you need to introduce 7 numbers, okay? 1 for each of the types of crops that we have in the model. And so this will need to be the share of land that is used for organic agriculture for grains, let's say 0.01. Then we add a comma and we add in the percentage for wheat. Then we add a comma and we add in the percentage for barley. Then we add a comma and we add in corn. Okay, so basically the Vensim knows that there are 6 subsets, 6 types of crops in this variable, and so it needs to have 6 numbers.
7, I think.
7,
Yeah.
yes, sorry, 7.
Okay.
Okay, and it is correct, you don't have to put the comma at the end. So the last one comes without comma. Now, this is simple because you have a number. Right? It could be the same for all of them. It could be different for all of them, but it's just a number. If you were to use different equations to determine the dynamics of one crop or the other, that you cannot put an equation and then comma and then another one and then comma and then another one. Now, this is when you can use the add equation button. Okay. So it can create a parallel equation. You can add it now. We can remove it then. It adds the possibility to add a parallel equation where you can say this equation only applies to wheat, for instance. So under subscript in the field, you can add whatever, grains in this case. This equation only applies to grains. Then you can add another equation to say, okay, this next one only applies to wheat, or the next one only applies to barley. And so you can have customized equations for each of the crops within the same variable. Okay, within the same initial land variable. And then you can select the equation you want. Now, given that this is simple and it's just a constant factor, we can remove equations 2 and 3 at the moment and just keep the first one with the percentage, the equal percentage for all of them, okay? Then we can press check syntax and then, okay. Yeah, you have removed the variable, renamed the variable, so it's asking for a confirmation. Okay, press okay here. So we have the initial share, which is a percentage. Now we need to make sure we review the land use for organic agriculture again to see if we're using, in fact, the share formulation. Okay, so what is the initial value for this equation, for this variable?
This one?
Yes. So pay attention, the unit of the variable is hectare, right? But the initial value, we should have hectare as unit, is instead a share. So how do we go from share to hectare? We need to multiply the share by a land quantity. But what land quantity we use? The initial share that you have added is initial share of what? Total agricultural land or conventional agriculture? Total agricultural land. So we need to go find what is total agricultural land and what is that variable. I can tell you now because I have it, I look into my model, but otherwise...
But we have to put this connected with... Oh, wait, no, we cannot.
So if you want to call up a variable, you can click on the right side of the subscripts, you can click on variable, or you can close the equation and go find it and bring it up as a shadow variable.
Oh, you mean this is initial land used for agriculture? We multiply it by initial land used for agriculture?
Possibly, yes, because it's an initial value anyway. So if you click on variables, you see on the right side at the center of this pop-up window for the equation, you have a button called variables, and next to it you have the drop-down menu with causes. So there seems to be a delay between the sound and the video.
Have variable and then?
No, it was inside the variable pop-up window. So if you go to land use for organic agriculture with the equation tool and you open it, on the right side, you have a button on the right side of the subscripts. Yeah. You have a button called variables. If you click there, you can search for variables in the model. In our case, it's initial land use for agriculture. And if you find it, then you can then include it in the formulation.
How do I search it here? I'm sorry, where is the search here? Variables, right? Variables.
Yes, you have to click on variables. And I see the comment that is no translation, and it's about time to break, so we can take a break.
As I understand, problem. So we don't have Nurlan with us now.
Sorry, this is not where I wanted this.
Okay, let's fix this this equation, and then we break. Okay.
Initial land agriculture. Okay, so that should be okay, right?
Yes. So this is just to close before the break. It's to ensure that you pay attention to the inputs that you have, like a share, that these are consistent with the formulation that is required, in this case, for the stock. So the unit consistency comes also through the choice of equations that you make. Okay. So I suggest we take another 10 or 15-minute break, and then we continue with the validation. We need to look at one more variable, and then we can simulate the model.
Okay. Or for now, we can as an exercise, right? We can do that.
Yes. So if you want to have a time series, right, you should add, in case, an equation for each crop with the same or a different time series, basically. So if you want to do that, go back to the first equation. I'll give you a few pointers to equation 1. No, in the same variable, you have created 2 equations, right? You have added the second one. I could go back to the first one.
Am I even there? Wait.
No. In the transition from traditional to organic land table, in that variable.
Yes. Jesus. Okay.
Well, we have 2. We have transition from sustainable to organic land table, and we have transition from traditional. Or actually, we were looking at the other one. Oh, sorry for the confusion. But in case, let's do it here. So here you can add the subscript with the crop types. But in this case, if you want to have...
В этом случае по субскриптам, если мы хотим добавить уравнение по
the specific crop. So you can click on range in the subscript menu, and then go to crop types, and then select the specific crop that you want to use. Okay, let's say it's grains. Then what I suggest you to do is to copy the equation or the time series that you have there. Then click on add equation, paste the equation you have, and then add wheat has to be added just above, okay? And then in the equation, you can paste what you had before. And then here you can change the numbers, right? So that you already have everything set up, but you only have to change and adapt the numbers. And you can do the same with the next equation, with barley, and then with corn, potatoes, vegetables, and remaining, but then go in and change the numbers as needed.
It's just Just to make some differences. I'm not going to...
Up to you, we can make them later on in the calibration step.
At this stage, adding fruits will be difficult?
So fruits need to be added first as an element in the subscripts. So do remaining for now, and then once we have fixed everything we have now, we can think about adding fruits. And I'm saying that for one very simple reason. If we add fruits, we add them across all the variables that make use of the subscript crop types. But the moment we add a new component, a new element, that is fruits, we need to go back into all the initial variables to add what is the value for fruits. So I would want to add this one first, check that everything is fine, run the model, understand behavior, and then in case we go back to adding fruits as a next step.
Okay, so we have all 7 here.
Yes. So, and we can use the same type of approach for the other table. So if you close this variable, you have another flow that goes from sustainable to organic.
Oh, we can
you
just
see
for crops.
What I would do in this case, to make it simple, is close this variable. So either you use the same transition for all crops for now, or the other option is to copy and paste the previous variable, transition from traditional to organic land table, change the variable name so that you already have a variable that has the 7 equations and a table function set up, and then modify the numbers inside that variable. So these are the 2 options we have.
So to copy that, we have to
use the hand, select the variable, Control-C and Control-V.
That's it. So it's going to add 0 or something, right?
Yes, so because you cannot have 2 variables with the same name, yes.
Something happened. That's why it is now new. Undo. Replicate.
Yes.
Yeah, it's just those right here. Okay. It's just the place, it placed it over.
You can move it, exactly, you can move it down. Okay, so now you can rename this one. So what I would do in this case is select the variable tool, then click on the variable transition from sustainable to organic land table, the one you had before. Copy, select and copy the variable name. Okay, then use the trash bin, the delete button to remove that variable.
Okay.
And once that variable is removed, then you can rename this one with the same name of the other one. So you can click there and paste. Okay. And then you can connect it back to the equation that you have in the flow. Okay, so you see some of the potential shortcuts. Remember, of course, to adjust the numbers if you have data and they're driven by different dynamics. Okay, now let's try to do a model, check model. In the top menu, we go to model and check model to see if there are other problems with the subscripts that we may have not have addressed.
Yeah, crop types, transition from sustainable to organic, transition from traditional to organic.
So it says, in this case, transition from sustainable to organic land table is a special type and cannot be used as a normal variable. What does it mean? It is a lookup, it is a table function, right? What is the input of the table function? You can open the variable and we can see it together.
I think I did put a lookup, yeah?
Yes, but what is you have an input and output in the lookup. If you click on sgraph, you can see it clearly.
Input here.
Exactly, so input is time, right?
Mm-hmm.
So if the input is time, in the variable where we use the table function, what do we need to do?
Add shadow variable time?
No, we need to include time into round brackets. So when we use a table function, or a time series like in this case, we need to use it, and then into round brackets at the end of the variable name, we indicate what is the input. So if we go now into the variable land use for agriculture to organic agriculture, so the flow from conventional to organic.
This one?
Yes. We can see that the formulation is land use for agriculture times the transition. But since the transition is a table function, we need to add a round bracket, time, and we close the round bracket, because time is used as an input for that variable. Then you can press check syntax. It asks you whether you want to bring up time and connect it to this variable. You can say yes, okay. And then time appears on the screen. Now, this is a feature that you can only do with Vensim DSS. With Vensim PLE, you need to first bring up time as a shadow variable, connect it with the arrow, and then add it to the equation. In Vensim DSS, you can type the equation, and then if you type the variable or a variable name that is not connected with an arrow, Vensim DSS will bring it up for you.
Why don't we have it here, transition rate to sustainable farming? Because it's not a table. Okay.
You're not using a table function, yes. Yeah. Okay, you can do model and check model again and see whether we have still these two problems, or if these have gone away, we have others.
Subscripts.
So in this case, we say we have some subscripts, the crop type, that appears on the right. It appears when we have the equations, but it doesn't appear on the left. So this is the right and the left of the equation. So if you look at the equation field, you see equals, equation, subscripts, equals, and then you have the equation. After the equals sign is the right side. Before, when you have the subscript, is the left side. So in this case, you need to click on subscripts, the small button on the left, and add crop types.
Oh, Jesus. What is that?
Okay, so these are, if you see, it only says is not used in the model.
Okay.
So these, I think I said it once before. And in theory, in system dynamics models, everything has to be connected in one way or the other to something else. Like in this case, Vensim is telling you, pay attention, this indicator is not used in the model. So it's an output indicator. Is that correct, or are you supposed to link it to something else? Now, for small models, there is one thing you can do. If you click on the equation, in the equation field, okay, to make this go away, you can see supplementary, right? So in small models, it's fine to click supplementary every single time, right? When you have 15, 20, 30 variables. But when you have a model with 500 variables, you don't know until the very end what are the supplementary variables or not. So it's either something I don't do, or I do at the very, very end, just to clean up the model. The problem, though, is that if you end up making a modification and you end up using a variable you have identified as supplementary, you will get the opposite error message. You will get that you're using a variable that is supposed to be supplementary. So it doesn't add much to the process. So now that it seems that the model is okay, try and simulate the model and see what happens. First of all, we see if the simulation runs. So we have warnings, which is fine. We said warnings are not a big problem. They help us assess. You see it says below or above. It just tells us that the number is above or below the boundaries of a table function, for instance. But that's just for fine-tuning validation, which is not too relevant now. In my case, I suppress the warnings because they don't stop the simulation, and because I carefully check already what has to be the maximum and minimum values of the lookup functions. So we can close this window, and then we move on to the next step in validation. We want to see the numerical results of the stocks and the flows that we have modified. So in this case, what I do, I start from land use for agriculture, then go to the next stock, and then to the one for organic agriculture. I look at the graph and see if the results are reasonable, if the results make sense. Okay. So now what we see here is, first of all, the two simulations. We have baseline and then the data converted. And then we have, we have 4 simulations. So I would suggest to remove some of them to make the screen a bit easier to follow. I would remove the older simulations, the BAU and the green economy ones, and just look at the baseline and data. Then at the same time, we have selected many crops. So if you look at the graph now, you will see that you have these different lines. It's also possible to start working with one crop to make sure we understand what is happening. So if you go to subscripts in the top right corner, that tool for the subscripts, if you click on one of the elements of the subscript, you see it's not highlighted in blue anymore. The ones highlighted in blue show up in the graph. The ones that are not do not show up. So in this case, I would say click on none at the bottom of this window, and then select the ones you want to see. or just go ahead and pick one or two. I would just select one to see what happens. Okay, then click on the graph again. And in this new graph, first of all, you see just one line or one crop, grains, and then the two historical and Bayesian simulation. Now, this is land use for agriculture, which is very well aligned with the trend we had for the green economy scenario before. Let's go ahead and look at the other stocks. Let's look at sustainable agriculture next. Okay, so this one increases over time to offset the decline of the other one. Then let's see what is the organic agriculture land. Now, these are the easy ones to check because they were already there before. Okay, organic grows a bit too much, it seems. So first of all, let's do a test. We want to make sure that our land disaggregated into organic, sustainable, and conventional is never more than the total agricultural land that we have. So when we modify the model, often we add in specific variables. There are test variables to ensure internal consistency. So I would say, let's add a variable called agriculture land test. And this will be the sum of the three stocks, so that then we can compare the sum of these three stocks with other variables, with the variable that tells us what is the total agricultural land. So this is the sum of the three stocks.
Do we have to rerun it?
Yes. So first, make sure you add crop types as a subscript for the whole variable, or what type of variable we need in this case actually. What do we want to test? Do we want to test total land by crop, or do we want to test total agricultural land at the country level for all the crops for consistency?
Yes, let's test the total land for all crops.
Okay, so in this case, we need to sum up the land by crop, right? So we need to add that sum function that sums all the elements of the subscripts. Now, if we do that, we don't need the subscript at the top that you just added, because if you sum up everything across crop types, we want one number only, total number of hectares for agriculture, right? Not by crop. So then what you have to do is to type in a sum and then open round bracket just before land use where you are, yes? And then put the exclamation mark after the S of crop types at the end. So you're basically saying sum up everything, all the subscripts that come just before my exclamation mark. And then close the round bracket just after the squared one. Oh, you have to do the same for every variable. So it's sum, and then the exclamation mark, and then close the round bracket. And then for the next one again, sum and so on. So this makes so that you sum up all the hectares of land for each land type or land management type. Okay, then click on check syntax. Okay, then we can rerun the model. No need to change the simulation name because we have added a new variable. We're not changing the other ones. The screen is a bit slow in updating on my side. Okay, so we have 8 millions in this case. So close this graph and then let's select two variables at the same time. So basically keep the one you have, and then by pressing Shift on your keyboard, select also, if you go to the left side, there is a shadow variable called agriculture land use for crop production, which is basically our total land use for agriculture.
Agricultural land use for crop production.
It's a shadow variable, top left. So in other words, the sum of the three stocks has to be the same of the total land that is used for crop production. So let's see if you select them both at the same time, and then as you have done, you have the same graph. We had initial consistency. So the model initial conditions is fine, but then something is happening that makes so that we lose that consistency, right? So this shows that we need to pay attention to the flows, because if the stocks become too high, then what is the only variable that changes the stocks? It's going to be the flows. So we can close this graph, and if the problem is that organic land grows too much, then we can see what are the inflows to organic land and see if one or the other or both too high. So this shows that we have about 100,000 hectares, right, or more, in the case of land use for agriculture to organic, so from conventional to organic, that is transitioning every year. And if you add them up over time, then this creates the problem. It creates a massive increase in the stock of organic, but then it should also, so let's review this in two ways. First, is this number that we get here what you expected, or is it too big?
It's a bit too big, I would say. But this one is 1,000 through this, right? But we do get that.
So let's break down the problem in two ways. First, is your expectation of that transition based on the variables you used matched by the numbers? Meaning, what equation do you use for the land use for agriculture to organic agriculture? You have the land use conventional stock multiplied by the transition from traditional to organic. What is that transition value that we have?
Basically, we should end up with 40%.
I'm waiting for the screen to update so that I can see what we have. Can you open the transition from traditional to organic land table?
Yes,
Go
I
to
did.
graph.
Uh-huh.
Okay, so it's just my screen. It's taking time to refresh. Okay, so this is 40% of the stock, right, that you said you want to have. But this is the equation of a flow. So you're basically taking 40% of the stock out every year. So in 2030, you take 10%. In 2031, you take a little bit more than 10%. And so you're taking that portion out every year, right? Why instead you said it should be 40% of the stock by 2100, not taking out that percentage every year. It's just the total amount should be that. So we need to change the formulation. Now, this transition from traditional to organic land table should be called something like desired share of organic agriculture out of total land use for agriculture or of conventional agricultural land. Then we need to compare the stock of organic with the amount that is desired, and that will determine the transition pattern, okay? So we need to make sure that there is alignment between the way we see the policy working or transition happening and the mathematical formulation of the equations. Then I'll mention it quickly, but we analyze them one by one. There is a second factor to consider. The total land used for agriculture cannot go above the land available for agriculture. Mm-hmm. So that is a second aspect we need to verify. But first we can fix this one.
Shall we change that or shall we change the rate? We can just change the values in the table, right? That would be a bit easier.
So either you change the value and you make it a very small value, but then you test what is the share that you obtain. Like, so this could be 1% per year, not 10, 20, 30% per year. Meaning that if you have 1% per year and you go between 2020 and 2100, you end up with 80%, 80 years, 1% per year, something like that. So we can test that behavior. Now, notice one thing. If you've done this for grains, potentially you have to do it in the same way for all the other crops. What? So you can close this one and then do copy paste of the text version and add it to all the other equations. I see that you're a bit lost with where your mouse is going. You want to change the upper value of the axis, the vertical axis?
I don't see it here.
Right. So if you go to the top right corner of this pop-up window, you see Y max on the right side. You can set it manually, set it to 0.02 or 0.03. Better if you have it as smaller, 0.02. And then the lower one, you can set it to 0 instead of 0.009. And then you can see it's constant, somewhere in between, minimum, maximum.
Okay.
Good. Now, if you press OK here, then you can see the updated text version with round brackets. But this is just for grains. So you have to do the same for all the other crops as well. So this shows that when you have subscripts, if you use the same type of formulation for all of them, when you make a mistake in one formulation, you basically make it for all the other ones as well. So you have to be extra careful in reviewing the subscripted formulations. It is a shortcut, it saves time, but it has to be used with care and attention. Okay, then let's fix the other one as well, the other flow that changed from sustainable to organic land, because it uses the same approach. And then we can rerun the model and see if the change is more reasonable. Here again, if you may want to copy paste the other 1%. Just to make it simple. Now, while you're doing this, since you're starting to appreciate the beauty and the beast in building a model, the beauty is that you have to look at every single variable. This is not a prepackaged model where you just say, I know the equations are fine, they're based on literature, I plug in the data, let's see what happens. This is a model where if you really want to use it well, you need to understand every single variable. That is the process I go through all the time. So it's in a way, it's good and bad, but it's good because if you understand it, you really have a lot to learn and you can properly inform planning. But at the same time, it does take time and effort, especially if you're working on sectors that are not your own core expertise. So this variable has not changed, right? It's the same. What happens to organic agriculture and to the comparison of our agricultural land test?
So these are, the gray one is organic, and this one is sustainable. Brown one is sustainable on the bottom. Next one, gray, is organic, and this one, red, is total.
Conventional.
Yeah, traditional, yes.
So
Okay.
let's look at one thing here. We see that sustainable starts after a while, but organic starts immediately.
Yeah.
So this gives you the idea that you can also decide when to introduce a policy, how to phase it in, and so on. But let's look at the agricultural land test compared to the land available for crops to see how big the difference is now and if you have solved the problem. Yes, so it's better than before, meaning that we don't have that exponential growth in the red line anymore. But if we look carefully, the data, in this case, the data is the green line, that shows a somewhat constant trend. We can only validate the model if you're able to reproduce the historical trend, right? So at the moment, we're showing a trend that is very different from history. So we cannot proceed with this version of the model. If I go to Russell and Jenny back and say, here are the results, they will not be too happy, I guess. The same with you. When we do the training and consultations, and they don't think the model works fine. So we need to still fix the problem that we are allowing agricultural land for crops to grow more than it should, than the total amount available. I'll give you 5 minutes to review what we have in this sketch and try and come up with an explanation and a solution. I would like you to work among yourselves to explore what is happening with the model and what is the potential solution to use. Could we do that for 5 minutes? Then we review the solution together and we then take a break before we do the implementation of the changes.
Okay.
And Nurlan, if you need a bit of a break, we can have the team discuss internally and then we translate only the final answer. Up to you.
Sure, I can go to Russian channel now.
I would listen to the Russian exchange, so to see how much exchange we have, if it's a monologue or if we have more exchanges.
We have any, yeah. Проблема, если вы ее, надеюсь, поняли, да, это у нас получается слишком много земли мы используем. То есть вот здесь мы, это наше традиционное сельское хозяйство, это устойчивое, это органическое. Но получается так, когда мы их складываем и сравниваем с тем, что у нас вообще есть количество земли, которое у нас есть для сельского хозяйства, у нас получается очень большая разница. Вот это красное, это наша переменная справа, это наш тест. Получается, что у нас в нашей модели количество земли, которое мы используем по всем видам сельского хозяйства, растет прям какими-то жуткими темпами. А на самом деле вот это слева, то, что у нас зеленое, это данные исторические, и серое, то, что оно как должно быть. В принципе, у нас количество земли у нас не должно увеличиваться так сильно. Вот у нас 5 минут, чтобы решить эту проблему. В принципе...
Может, в тесте не все должно суммироваться?
Почему не все? Все должно суммироваться. А как? Мы же сравниваем количество земли, которое у нас есть вообще для растениеводства, и то, что у нас сейчас традиционное, устойчивое и органическое. То есть где-то у нас что-то не то. Да? У меня традиционное по 1% в год, грубо говоря, переходит в органическое. И устойчивое по 1% в год переходит в органическое. Вот это я подозреваю, что-то вот здесь, вот может быть, вот здесь что-нибудь такое. Вроде 1% немного, да? Тут у нас вообще ничего никуда не переходит. То есть, у нас в sustainable вообще ничего не переходит почему-то. Тогда у нас получается, что...
В органическом сколько процентов у нас? 1%, да?
1% в год у меня переходит. Из традиционного в органическое я написала, что по 1% в год все время. То есть оно у нас, в принципе, растет. Сейчас посмотрим, сколько их всего. Так. Грубо говоря, он постоянно на 1%. Давайте посмотрим. Так, это в год то, что переходит в органическое. То есть все меньше мы переводим, а потом мы вообще не переводим. Почему? У нас-то 1% в год, 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 должно быть одинаковое. Здесь, наверное, мы вообще дошли до... Всю землю использовали.
Здесь есть, что это за счет снижения общих земель сельского хозяйства. Как-то это
Гектар в
включено?
год. 1500 гектар в год. Вот доходим до 1500 гектар в год из устойчивого органического перевода. Мы так здесь и остаемся. Ну, окей. 1500 гектар.
Мы где-нибудь учитываем, например, если 1% убывает с этих с традиционного, да, то есть оттуда отход идет.
Должно убывать. Вот она у нас. Вот у нас функция. Вот,
Это organic. А это какой мы до этого? Традиционный? Conventional?
вот это вот land use agriculture, это традиционно. Земли в сельскохозяйственную минус то, что уходит в органическую, минус то, что уходит в sustainable, устойчивую.
А это одновременно происходит?
Да, ну, в соответствии с течением времени. А вообще у нас что-то земля used for agriculture уменьшается.
Это традиционная же, да?
Ну да, все правильно, так она должна уменьшаться. Да, вы правы.
А можно
Давайте.
еще раз посмотреть органическую?
Давайте мы все посмотрим вместе. Так, вот у нас традиционная.
Угу.
Несмотря на то, что органическая у нас увеличивается, традиционная у нас остается постоянной, а потом у нас идет рост устойчивой, тогда у нас идет снижение традиционной. То есть оно снижается только, грубо говоря, почему-то оно зависит от устойчивого. Такое впечатление, что вот это вот как-то не очень используется в модели. Ну, в смысле, как бы, да? Хотя теоретически так, традиционная. Если мы их просто тупо сложим, 400 где-то меньше, чем 300, это 680 где-то, и еще 130, 700, 800 где-то получиться должно. А тут у нас сколько?
Где-то 800-900, да?
Угу. У нас почему-то в тесте аж по 2 миллиона, тоже как-то побольше, 1,5 миллиона.
Можно мы функцию посмотрим?
Фу, вот
Нет,
это
вот это, где у нас проблема, вы же говорите, это agriculture, мы там не можем посмотреть.
Вот это?
Нет, да, не можем, да? Это же влияет.
Нет, можем, но она постоянная. Постоянное количество, соответственно, оно должно быть равно. А вот это вот в тесте давайте посмотрим тест. Тест, в принципе, что мы складываем то, что у нас для традиционной используется, то, что органической, и то, что устойчивой. По идее, вся эта сумма должна быть равна вот этой. Но она не равна каким-то образом. Я вот эту переназову, а то что-то она у нас немножечко...
Почему каждая из них по отдельности должна суммироваться?
Почему нет? А куда у вас еще должно что-то? Как еще? У нас только 3 вида использования.
Только
Да?
в общем скобку написать не каждому из них.
Ну вот в общем, вот мы их складываем. Вот сюда.
Нет формулы.
То есть мы суммируем всю землю, которая используется по
У
традиции.
нас идет, каждая из них суммируется, и еще в общую сумму идет. Формула, вот смотрите, это там сумма идет первая, идет это что, традиционная, да? Потом следующая сумма. Здесь, я думаю, Венсиум понимает, надо вот эти все там, наблюдаемый год суммируются, отдельно традиционная, потом дальше органическая отдельно суммируется.
Да.
И суммируется отдельно, получается, так, устойчивая, да?
Все
И
правильно.
обратно все это суммируется. Ну, это математически. Может, просто...
Нет, математически здесь вот эта сумма стоит только для того, чтобы делать сумму всех вот этих типов растительности. Вот здесь мы делаем сумму, почему вот здесь ставится сумма всех земель традиционного, да? То есть мы землю, которая используется при традиционном сельском хозяйстве для всех вот этих видов растительности. Потом тоже всех видов растительности для организма. А потом то же самое для всех видов устойчивого для растительности, да? То есть тут я...
Интересно.
Да, может сумму везде уберем, попробуем.
Нет, но это...
Данные, например, на органические и устойчивые у нас как бы вбиты, да? Я знаю, что на...
Ну, они у нас вбиты, потому что, в общем, я поставила, что на 1% увеличивается каждый год у нас площадь органических земель. То есть, возвращаясь к тому, что я убираю из традиционных земель 1% каждый год и убираю в органическое. Потом из устойчивых земель я тоже убираю 1% в органическое. Но, честно говоря, из устойчивых земель у нас-то нет ничего. Потому что из устойчивых земель мы ничего ничего не переводим в устойчивые земли.
А как тогда всем считать по типу растения? Или там, не знаю, как, может, там проблема где-то?
Нет, я думаю,
Просто
что
если
вы...
так посмотреть, вот тест она показывает 3 раза больше, да, чем ожидаемое. 1,5 миллиона.
Показывает. Сейчас давайте еще раз посмотрим. Вот тут наш...
Насколько они больше показывают?
Но это не проблема не в том, что мы 3 раза складываем, потому что это в чем-то другом проблема. Если бы оно сразу вот здесь вот в 3 раза подпрыгнуло бы, да, достаточно маленькое расхождение в 2000 году.
Да.
А потом все больше и больше. А здесь по 2 миллиона, а здесь 1025.
Ну, у нас, по-моему, с 2010-го там идет, правильно?
Ну вот здесь вот, я бы сказала,
И вот с 2010-го у нас рост идет.
вот здесь оно тоже не совсем одинаковое. Почему? Почему у нас с 2000-го начинается? Я вообще начинала вводить любые изменения, только знаете, когда? В 2019 году в любом случае. Очень странно. Я любую политику начинала вводить с 2019 года. Поэтому почему она вот здесь вот так делается, не понимаю.
В историях где-то 2000 года имеется, поэтому...
Да, понятно, но предварительно модель-то должна, по идее, была быть одинаковая с тем, что у нас исторически имелось. А она не одинаковая. Причем с 2000 года. У меня вот эта политика начинается перевода земли, да? Она начинается у меня, видите, с 2019 года. А, подождите, давайте посмотрим, как график. Да, с 2019 года. Сейчас. Давайте, она у меня, может, начинается как-то с другого места. Как бы нам ее посмотреть, да. Она-то с 2000 расти начинает. Не трогать 19 год. А, может быть, она... давайте мы сделаем так. Сейчас мы в тейбл... Нет, я думаю, нам надо вот в этой таблице... По-моему, Вензи думает, что если я ничего не говорю, то она всегда такая будет. То есть, как бы он с начала времен это делает. Давайте мы 2000 напишем 0. И посмотрим, что у нас будет. И теперь давайте посмотрим, что у нас будет. Ну, с нуля, по крайней мере, хоть начинается. Давайте мы напишем еще 18. Попробую я сейчас еще попробую свою идею. Давайте мы напишем еще 18, у нас тоже 0. У меня такое впечатление, что она нам везде поставила. Окей. Ага. Вот видите? Это значит, что он у нас предполагал, что она прямо с самого начала у нас менялась. Давайте я вот это поменяю. Вводим не с самого начала нашей модели, а только в 2019 году, 2018 у нас 0. Извиняюсь, 2000 0. Окей. Ну, хотя бы. Наверное, это не очень что-то решила, но traditional. Давайте сейчас посмотрим все 3 вместе. Ну, хотя бы они начинаются, когда я хотела, чтобы они начались. И более или менее как-то они...
Вы знаете, что экран поздно приходит.
Теперь, по крайней мере, они начинаются хотя бы там, где я хочу, чтобы они начинались. И дальше у нас почему-то наше пустое хозяйство в 40-м году прекращается. Рост, а органического нет.
Почему нет?
А сейчас я посмотрю, потому что устойчивого...
Органический есть, устойчивый, вот серые постоянные.
Apologies for the interruption. So I see progress has been made, but we can also discuss the solution together. I'm wondering, do you want to take a 5 or 10 minute break and then we finalize this part of the model?
Yeah, I would like to find solution.
Okay, good. So can you summarize your considerations and where you think the problem is and therefore the solution could be?
We have not solved it, but at least we have seen that I have made an assumption in the table. I forgot how Venzim works because it is actually...
I cannot hear you anymore. I'm not sure if it's me.
Actually,
or
consider
you.
that. Can you hear me now?
Yes, now you're back.
I had to set this to 0, at least because otherwise Venzim thought that this policy of 0.01% was from the beginning of the model time.
Correct.
Maybe that's the thing as well that we have to do here. I don't know.
But no, so if you have a value from, say, 2018, Venzim takes the same value for all the years before. And then if you have a value until 2020 and nothing afterwards, it takes the same constant value for the future years as well. So what is the change that making this aided, this modification to the model has created for the agricultural land test when you compare it with the available cropland.
It became a bit closer, but not close really to what it should be. It still is different. Still is much bigger.
Okay, I'm waiting for the graph to show up on my side. Yes, so there is a smaller difference, but there is still a difference. So there is something else that needs to be fixed, right? I'll be back in 1 minute, okay? I'll give you a hint before I restart my laptop. If you show the model, then there is a decision rule, a variable that determines how much land we put into traditional and sustainable agriculture. Look at the variable desired agriculture land conversion and see the one above, desired agriculture land conversion, and see what are the factors that are included in that formulation and if you need to add something else. I will be back in 2 minutes. I'll just restart my laptop and connect again.
Если у нас switch на устойчивое сельское хозяйство равен 1, если мы включаем этот переключатель, тогда нужная нам земля для всех наших разных видов выращиваемой продукции, умноженная на необходимую часть сельскохозяйственных земель, agricultural by crop type, multiplied by desired share agricultural and sustainable, минус земля, уже используемая для устойчивого сельского хозяйства. Тогда перевод земли в устойчивое землепользование будет равен чему? Тому, сколько нам нужно для устойчивого для каждого вида продукции, умножить на процент общей земли, минус то, что устойчивое.
А здесь еще органически не отнимаем?
Разве нет?
Органически землю не отнимаем здесь?
Пока нет. Наверное, надо. То есть он, наверное, поэтому и сказал, что надо тут что-то посмотреть внутри и исправить. Почему здесь две формулы? Я что-то... все правильно. Если у нас switch равен единице, тогда у нас нужно перевод в устойчивую землю вот этому равен. Если у нас отключен switch, тогда у нас если у нас устойчивый switch включен, и если скорость перевода для каждого вида растения больше нуля, тогда это будет равно максимуму либо нуля, либо политике перевода в устойчивую каждого вида, уже которые используются, либо политики.
И отнимается устойчивый.
Тут, в общем, я так предполагаю, говорится следующее. Если мы включаем политику внутреннего, как сказать, помните, он говорил, что можно внутренне установить, сколько нам нужно устойчивого сельского хозяйства, а можно внешне. У него здесь внутренне определяется. То есть оно определяется из условий. Внутренне определяем, тогда оно равно вот этому. Если мы политически определяем, то политически определяем. Окей, переводится. Policy land converter. Так оно, по-моему, и равно. Но я так подозреваю, что у нас в устойчивое ничего не переходит просто. Я могу быть, конечно, не права. После 2018 года.
Hello, hi again. Okay, let's see if it's better.
We have something really, really strange here. Am I understanding what this is? There are two switches. First switch is you decide to determine sustainable farming, the share of sustainable farming land that you need within the model.
So this says if the switch is on, so if the policy to do sustainable farming is on, then use what comes after the comma. Otherwise, use the rest.
Yeah, but that's not quite, these are two different switches.
Yes, it's a nested structure with two switches, yes.
But this switch says, if we determine the sustainable farming within the model, right? So if we see how much land we need for sustainable farming within the model, then we determine it this way. If we determine it through the policy, and the conversion rate is above 0, then we determine it through the policy.
Yes, so one is fixed by a specific ambition. Yes, the second one is fixed.
We looked at the policy and it's like 0?
No, otherwise, the last one, if one switch is on, use this formulation. Otherwise, if another switch is on, use a different formulation. And if no switches are on, it's 0. There is no conversion to sustainable agriculture.
But at the moment, we have switch sustainable farming at 0, and we have switch endogenous sustainable farming at 1. So we are determining how much sustainable land through this first equation. So
Yes.
desired agricultural land by crop type multiplied by desired share of agricultural land sustainable minus that it's already sustainable.
Yeah. But this is not the variable to look at first to find the solution to the problem.
Okay. Which one?
The first one to look at is the one above, is desired agricultural land conversion. That is the amount of land that has to be traditional, okay? And this is formulated now so that you take the desired agricultural land by crop type, okay? And then you subtract the portion that is sustainable, and then you compare it with the land that you already have that is traditional. So the trick is here, in a way that you have to say, now that we are adding organic, the land that is traditional should be based on the total number, what is sustainable, and what is organic. If you don't add what is organic, then you're going to generate more land requirements than the land you actually have.
Then 1 minus desired.
So the first two elements, desired agricultural land multiplied by 1 minus desired share of sustainable, takes care of the land that is sustainable. So this could actually be replaced by a land used for sustainable production. Then you can do minus, okay, the organic one. So how do you include the organic here?
Well, either here, so after this one?
Yes, but with what sign? So you have to say, if I have, what do I want to convert is, if I want 100, I need to do 100 minus what I have sustainable, minus what I have organic, okay? So that I have the net amount of land that I would want, compared with, and so minus, the traditional land that I already have. Understood?
Наверное, по той же логике, как предыдущая.
I guess following the same train of logic as the previous one.
Yes, it's the same what if formula. The equation, the first part of the equation should be desired agricultural land by crop type minus, let's change the times 1 minus desired. So we say this is the total amount of land that we want, minus the land that is sustainable, minus the land that is organic, minus, you can search the variable, or it would be a land use for sustainable agriculture. Continue typing, or search land use for sustainable agriculture, and then for organic agriculture as well. Minus land use for organic.
Land used.
Okay. So you're taking now the total land that you want, minus sustainable, minus organic, minus the land that you're already using for traditional agriculture, so that the difference is only the additional land. It's the value of the flow. Now you can bring crop types above, if you like, on the same line. That doesn't make a difference, but aesthetically it's easier. Then you have the second portion of the equation. If you have sustainable farming, then you have the switch for sustainable and not endogenous. You have desired agricultural land by crop type, then you already have minus land use for traditional, then you have minus policy land converted to sustainable, which is the policy-driven explicit approach. And then you also have to do here again, minus organic. Go down with the vertical bar, because there is probably the subscript. Just scroll down entirely. Yeah, sometimes it's been broken up. So after crop types, you can do minus organic. And if you like, we can simplify this and just have one switch without having the potential policy-driven and the specific endogenous formulation as you prefer. Okay. So now if you say yes, it's basically telling you you're using inputs that were not connected before. So if you say yes and close the pop-up window for the variable, say okay, then you will see the shadow variables appearing next to this desired agricultural land conversion. Well, not shadow variables, they're in the sketch. So it has created the arrows, the blue arrows from the two stocks of land use for sustainable agriculture and land use for organic agriculture. So now change the simulation name, call it baseline 2, and then run the model again. Because now we change the simulation name because we have in fact made changes to the equations, and we can compare what we've done before with what we have done now. No check model, sorry. You can run the simulation and then compare the results to see whether the model is fine. Same as before, agricultural land test and the desired agricultural land by crop type, and we'll see if you're getting closer. What is the new simulation? Is the blue one, right? And the old one is the green one.
I just wanted to say it didn't work.
Yeah, you have to be careful the simulations you look at. But I think we won the prize in this case, right?
You did,
Now,
yes.
this is not the only change that we need to make, though, right? Not the only one. If you look closely, there is a tiny bit of a difference before 2010. And so we have now only fixed the conventional land. We haven't fixed the formulation for sustainable. So there is a quick test that we can do. What if you run a new simulation where we have a big change in the flow from sustainable to organic? Now let's see what happens in this case. Let's call it baseline 3. We increase that transition table, make it 10%, just to see what's going on. Just for grains, or make it big, a big change so that we can see it.
Big enough?
I would think so. So let me check how big are grains in relation to the other crops, so that maybe we just modify this one instead of all the others. Yeah, grains are by far the largest. So I think we can see the difference. Then run the model again. And we look at the same two variables. We look at the agricultural land test and the desired agricultural land by crop type.
How do you zoom in?
Now, there is no change. Why? We are affecting sustainable agricultural land, right? Is the policy switch for sustainable agricultural land on or off? So the switch endogenous organic farming or sustainable farming. Let's try and turn that one on, because I think it's 0 now, and then see if the results change.
I think it's off. Sustainable farming is 0. I know we have checked. Okay,
yeah, I think it was the switch endogenous farming that we had to look at.
Switch endogenous was already on.
It was before, but in this last simulation you have created, it was 0, right? You switched them off before, both of them, I think.
Look, endogenous was on, and it is on. Shall I turn it off?
No, keep it 1.
And
let's check one more thing.
Sustainable farming on as well, and nothing has changed.
Okay, then let's see what is your land use for sustainable agriculture, the stock. What numbers do you get there if you open the graph? Okay, you have about 100,000 hectares, and you have a small reduction over time up to 2050. Let's see what is the value you have in the stock of organic agriculture for grains, if it's similar to this change that you have here. No, it's 600,000. So this seems to be too big, right? But you see that there is a difference now. There is a difference in baseline 3 when you have both switches on, right? And the simulations you had before. So I wanted to show you that you have to do validation to see if the structure of the model is fine, both with the policy switch off and always with the policy switch on. Because now you end up with 600,000 hectares here. Let's go see, again, the comparison between your total land, calculated from the 3 stocks, and the available land. Okay, so we don't see the big change at the end of the simulation, just a small one. So let's go see the stock of traditional land, because that one should decline quite a bit to keep this consistency. And sorry, my screen is very, it's not updating quickly. I don't know if it's the same for everybody else.
Yeah, there seems to be a lag.
Okay, so what is the problem you see immediately here in this land use for traditional agriculture?
It goes to minus.
It's negative. Yeah, so that is a problem. So we have the stock of organic agriculture increasing way too much now, and that makes so that the stock here goes below 0. So there are 2 things that we need to do then. We need to make sure that there is consistency in the sustainable agriculture land as well, meaning that sustainable agriculture cannot increase too much. So we need to look at whether we want to change the desired amount of sustainable to take into account the fact that you have organic as well. So subtract potentially the flow that is sustainable to organic from the potential expansion of the sustainable stock. And then we need to add a policy check, meaning that if we want to increase organic agriculture too much, up to the point, if there is a policymaker that says I want 2 million hectares of organic agriculture, once we know that we have only 1.5 million, we need to add a check in the model that allows us to stay within reasonable outcomes. Then we don't go beyond what is reasonable, which in this case is we can never have an amount of land that is negative. It's just not realistic. So this is also to show you that once we make changes, we need to do an assessment of the model and validation for different scenarios, with and without policies. So we need to do a bit of debugging of the model to make sure that everything we add is consistent with everything we had before. So let's see, for instance, what happens in the desired agricultural land conversion. What is happening in that case? What is, if you look at the graph, is that number going below zero at some point in time or not?
Yes, rather quickly, to be honest. As soon as we start our policies, it's like...
Right, so can this number be less than zero?
No.
No, so we could already introduce a potential change here. Normally, to avoid that the number goes below zero, we use a max function. We take the maximum value between what is calculated and zero, so that the variable can never take a negative value. So that could be one option. Then let's see what happens in the other variables. I guess the change in agricultural land follows the same trend. And if it's negative, it generates different types of changes in the stock of land use for agriculture or traditional agriculture. So the change in agricultural land, what type of trend it shows? This is the change in agricultural land, yes. So this one follows the value of the desired one. But if this is an inflow and it takes a negative value, what will it do to the stock? So we have to make sure that if you have an inflow that is supposed to be an inflow only, then it never goes below zero. So one thing we can do then in this equation directly, because it's the inflow, is to put in the max function. So we type in max, open the round bracket, 0, and then comma, the equation we already have, and then we close the round bracket. And let's see what type of results we get. So this one is the change in agricultural land. You have added the max value, right? Yes, yes, you have added that. There is that delay, so I was wondering whether it was already there. So let's see what happens now in the stock of agricultural land.
That one, the traditional one.
Yes, traditional one.
Yeah, it's above zero at least.
So it stays above zero, right? And it declines linearly. Now let's see the total amount of land, if it's consistent or not, the test amount with the available one. And then we also check the change in the land use for agriculture.
Extract some of the baseline is okay. Should I take out some of them?
No, you can keep only baseline 3, which is the one with the policy scenario on, because you've seen that the other ones already work. So in this case, the new scenario, then the latest one is the blue line, right? And we see that there is a problem. Now, when the policy is on, this number, total land, increases a lot. Let's try and figure out why that is the case. It's because we are avoiding a massive decline in the traditional stock of land. But at the same time, we're allowing sustainable and organic to grow. So what can we do to fix this then?
We can limit the growth of organic and sustainable.
We can limit the growth and make it more reasonable, yes. Or the other option is to remove the max function we have considered now, which is a net flow. See, this is a change in agricultural land. That's why I mentioned if this is meant to be an inflow, but it's not actually an inflow, this is meant to be a net flow, a net rate of change, right? Then we may consider things in a different way. So now we have tested that removing this one removes the check we have on total land. So this is the one that allowed us to make it work. In fact, if you rerun now baseline 3 without that max function, and we compare again agricultural land test and desired agricultural land, or agricultural land use for crop production, and waiting for the graph to come up. You see, so that max function that we've introduced removed the stocks being imbalanced. So when we do a test and decide what to change, we can test it, right? We can test a modification, we see what change it leads to. Then in case we go back to the previous formulation or we approve it. A lot of model development is about testing what happens when you make changes, so that then you can decide what works, what doesn't work, and what needs to be adapted. It's the only way to properly understand how the model works. So now we know that the total amount is fine, but if you look at traditional agricultural land, we still have the negative sign. Let's go check that one. But if we still have a negative sign, then we know that the max function is not the solution. Actually, that creates even more of a problem. So let's go see if we can now reduce the conversion to sustainable, because we also have organic, and see if that change makes things more aligned with the total data. So the one we need to look at is the change in sustainable agriculture land.
We want to look at the graph, okay?
Or just modify the equation. So you see here there is a massive increase in sustainable agriculture land at the end of the simulation, and that corresponds to when the traditional land stock goes below zero, right? So let's try and figure out what is driving this big increase. Is it policy? Is it an internal dynamic? So we can check the policy assumptions, the desired sustainable agricultural land conversion. How big is it? How does it change? Okay. So what are the causes of this one? What is affecting this one?
Desired by the switch and by desired share.
So let's see what is the desired share and see if it's too high. But this is, after 2040, stays constant. So probably not the problem, right? There is no massive change there. So it must be something else.
So desired agricultural land by crop type.
Well, that is the input for all the variables. So it shouldn't be.
So
What is the policy land converted to sustainable farming, the blue one? What is the value for that one, the graph? Okay, this one turns out to be negative. So something is off here. Maybe, now this is a way of checking what works in the model, maybe because we had a target for having sustainable farming. And we are now going beyond the target. And that is because we have more sustainable land and organic land elsewhere. And so it's the policy mechanism we already had in the model, which worked before, which goes a bit off balance now that we are adding organic. So let's try and turn off.
I cannot hear anything.
Okay, so given that the problem is driven by a policy mechanism, let's try for now to turn off that policy mechanism and see if the rest of the model works fine. Because if the rest of the model works fine, then we know that the problem is in the policy mechanism and we can fix it later. So what is the switch that activates the policy land converted to sustainable farming?
This one, switch sustainable farming.
Well, we have to go into the equation to figure out which one activates it, right?
Switch sustainable farming.
So what if we turn this one to 0 and we turn the other one to 1?
Yes, it's already 1. Save. Shall I change the baseline?
Yes, yes. It could be 3A or 4. Yes.
These both are okay, for most part.
Yes, you see we don't have that small increase at the end as well. Then let's see the stock of traditional land and sustainable and organic.
Traditional is here. Traditional is still minus, even more minus than before, even faster.
Yes. So what was that doing before? Before, we were having a negative change for sustainable land, which means that it increased artificially traditional agricultural land. Right? Mm-hmm. We have removed that one, which seemed like a big change, but in the total, it was a small one. But we haven't removed the inconsistency. So the only thing that we have left to check is that desired amount of sustainable land and how that can be modified to take into account the land use for organic agriculture.
This one.
Now, I'll give you the solution because I need to leave very soon, 2 minutes. But go back to the model and see one thing. We are modifying conventional land, traditional land, by using total sustainable agriculture and total organic agriculture. On the other hand, there is only a portion of organic agriculture that comes from traditional. Mm-hmm. And there is only a portion of organic agriculture that comes from sustainable. So we should take into account the relative share of the organic agriculture land, whether it comes from traditional or sustainable agriculture, and only take that portion in the desired conversion for traditional and sustainable land. Otherwise, if we take the total amount as we're doing now, we're taking too much out of traditional agriculture, when in fact, some of the organic land will come from sustainable agriculture. So we need to apportion consistently the amounts across the different stocks. Mm-hmm. Now, since we have about 1 minute left, I want to receive your thoughts as to how you think it's best to proceed. We had a very clear question that we asked ourselves a few times on Tuesday. That is, can we make all these changes by the end of July? And I said it takes quite a bit of time. I guess you have proof today that it's a process, right? It requires the investigation of everything in the model and how it works and the cross-checking of the changes you're making to the rest of the model. And we are far from completing this sustainable and organic agriculture component because then we need to disaggregate fertilizer use, maybe water requirements, costs, and so on and so forth. Mm-hmm. So I would like you to, if you can stay on a few more minutes, I'm sorry I have to leave. I would like you to think about how you see this happening. If we should work in this session on a few specific targeted changes, continuing on agriculture, working on energy or tourism, and then I can work on others on the side and show you what I've done. or whether you want to work on all of them one by one, but in smaller groups as opposed to plenary, I rely on your judgment. As usual, advantages and disadvantages for every option. If you do everything together, one by one, step by step, you get to learn a lot more, but it takes more time. And that's why we were discussing on Tuesday about the timeline. And if you have 3 months, I think it's feasible to work together on this. But I think it makes sense that we discuss a bit more about whether this is the right option or not, or that you tell me what is your preference. Good. So I'm sorry that I have to go, but if some of you cannot sleep without having the model that is working, please send it to me. I will fix it. It won't take a long time. I will send you a list of the changes I made so that then you can continue working with a correct model.
Okay, sure.
Okay.
I'll send you the summary of what we decided, or maybe Genevieve will, or somebody will.
Perfect. And then as you do that, please confirm if we should have the session next Tuesday, or as we said, we could do bilateral exchanges and then we meet again on Thursday only. I think that was the decision we took on Tuesday, but just to confirm. Okay?
Sure. Thank you very much.
Thank you, and enjoy the rest of the day and evening.
Yeah, you too. Thank you.
Bye. Bye, everyone.